Hello, everyone. Thank you so much for joining this talk. Today, I'm going to talk about fast finality and touch on why you should care about it in the context of bridge building. A bit of background from myself. I feel privileged to be part of the F3 engineering team at Filas right now. You may remember me from past adventures such as CARB2 format, IPNI, Boost, and so on. My specific interests are in content addressability, routing, and composability. I specifically am also interested in data onboarding in Filecoin, overall large-scale critical systems, the type of systems that would go down, somebody would complain or wake up, and then I have a bit of background in working on DHTs specifically. So today we're going to talk about Filecoin, fast, and finality, why you should care about it, and what's going to come next. So it's going to be a hopefully pretty straightforward talk. Before I begin with the Filecoin part of this, I want to point out two excellent talks from previous Filecoin Dev Summits. First one by Alejandro, which I think happened in FDS Denver this year, and then the second one by Marco, which happened last year. And both of those sort of talk about, if you look at the Marco's talk, it kind of takes you into a journey of how the F3 design came about. And then Alejandro very nicely lays out different ways by which we could implement consensus and why F3 is going to be the main consensus algorithm, comparing different advantages and disadvantages. This specific talk is just primarily targeted at builders. So the time doesn't allow me to go in deep into details. Also, that's a great way to avoid hard questions by you folks. So I'm going to skip those. So please go have a look at those talks for deep dive. So Filecoin EC. I think most folks in the room are familiar with Filecoin EC. Long story short, as the epochs progress, there is a decaying probability of change when we look back in time. So after 900 epochs, that probability is low enough such that we can say, you know what, that specific tipset is not going to change, and we're going to take that as final. It is extremely simple, but also extremely effective. If there is one thing you need to take away from current Filecoin EC is these three words: availability over consistency. And these are basic fundamental distributed systems trade-offs. And what does that mean? It means that the finalized tipset might change within the period of 900 epochs, but the chain would always be able to make progress, right? So you can't rely on the latest tipset to be the final one, but you will never be blocked by a consensus as you're carrying on, which is extremely important for any blockchain network. So remember this: availability over consistency for current Filecoin EC. But let's overthink this a little bit. I talked about the decaying probability of change when we look back in time. What that means is that things could change because we are prioritizing over availability. And what that means for bridge builders is that reorgs could happen. And when reorgs happen, things get extremely expensive because bridge builders, what they're trying to do is trying to do the hardest thing, which is to play nice across multiple chains. And if the state changes under your feet, then you obviously have a lot of problems to go back. And if you have told customers something, you're going to have angry customers that are going to tell you, hey, you told me my transaction is final. What happened? And obviously, there's another problem here, which is, I think, arguably less important in my humble opinion, but it is certainly a blocker. And that is, it could take up to 7.5 hours. That's 900 epochs, 30 seconds each. What you see in practice, though, is that most exchanges use about 200 epochs. I think that goes about 1 hour or so, and they just call it final. And what they're actually doing there is that they're taking the risk of reorgs, right? There may be some calculated risks that would reduce the level of churn across the customer bases of a bridge, but at the end of the day, it is a risk. Right? So if you want to build bridges on top of Filecoin today, you basically have to choose between these two trade-offs. You either have to give up being a trustless server, basically just delegate all the requests to some full node that makes the decisions for you, and there's no way for you to actually infer that the things you've given are right, or give up running a low-cost bridge because you have to run a full node and does the full consensus and so on. So trustless or low cost, you're gonna have to pick one right now, right? That's the world we are in just now. Enter F3. So F3 is a totally new protocol for achieving consensus. It actually builds on top of the current EC process. It can finalize blocks within only 2 epochs. So we've gone from 900 epochs to only 2 epochs. That's pretty amazing. And most importantly, for any bridge builders, you should listen very carefully here. There are no reorgs. So after something is finalized, it is final forever. And I think that is the biggest, most impactful thing about F3, right? Which provides a much better user experience for users of those bridges, and obviously much better operational cost and complexity in terms of design for bridge builders themselves. F3 internally uses a consensus protocol, which is called Gossip BFD. It actually runs on top of Gossip Sub, which is a Gossip protocol written on top of libp2p. It's powering Filecoin today. The thing about Gossip Sub is that it's a best effort broadcast. And that means it doesn't guarantee that messages are delivered. It also doesn't guarantee order. So these things are basically reasonable characteristics of a real decentralized network. You can't get away from just not having these unless there's some specific trade-off, like giving up speed and so on. And most importantly, Gossip BFD is resilient against best effort broadcast, and it has built-in ability to rebroadcast messages if they get lost and so on. So that provides you with a high confidence that in almost majority of cases, the blocks are bound to be finalized within 2 epochs or so. The fundamental of Gossip BFD is very simple. So what it actually does is there is a EC syncer which syncs the chain. Then EC syncer would pick a prefix of the chain, passes it to F3, and F3 finalizes it, provides a proof for it, and returns it back to EC chain, and then that becomes final. So this is basically essentially the main event loop of the entire system. The main thing to point out here is that we are turning that fundamental assumption that I talked about in the beginning on its head, and we say in F3, in order to achieve fast finality, we are going to swap the trade-offs a little bit. So rather than concentrating on availability over consistency, we are concentrating on consistency over availability. And I'll explain what that means in a minute. Can I ask the slides to be refreshed, please? I think we're missing a few. Great, thank you. Right, let's go back a little bit. That's it. So the main takeaway for you from this from F3 is that it is swapping the fundamental trade-offs of distributed systems. So rather than making availability over consistency the trade-off, we are changing it in F3 to make it consistency over availability. That means once something is final, you can absolutely make sure that you can be sure that it's final, but the protocol at some point might be struggling to finalize something, and I'll get back to that. But it will not if we based it on top of the EC. So what actually happened here, we have consistency over availability for the majority of cases where the network is operating healthily, and then we fall back on the EC to switch our strategy to availability over consistency whenever the F3 fails to finalize something over 900 epochs in a highly unlikely case. So right here is the thing that I really love about distributed systems, and that is, in academia, you talk about these fundamental trade-offs between availability, consistency, scalability, and so on. But one thing that often fails to get mentioned is that at runtime, you can change your strategy. So in a production system, you could have a combination of strategies that overall would assure the health of the system, but reacts to the needs of the users. And that's what we have here. So this is one of the unique things about the F3 right now, which is at worst, it would be just like the current EC. And in majority of cases, it would be finalizing within 2 epochs, and it would be finalizing forever. Yeah, I covered this one. So just a quick distinction. When I say F3, I mean the interface that interacts with the GPBFT, that is the protocol for consensus, to then interact with other Filecoin nodes, such as Lotus and so on. But conceptually, this is the main event loop, which essentially you get a chain, you get a prefix, you pass it to F3, F3 runs GPBFT, produces a proof, pushes it up the chain, and that becomes fine. Diving a little bit deeper into Gossip BFT protocol itself, just a quick disclaimer. This wonderful slide is stolen from Alejandro's excellent talk in Denver. I highly recommend looking at that talk. So what this slide shows is the different phases in the GPBFT consensus protocol. If you're familiar with a BFT, you can see things like prepare, commit, and decide are very similar to BFT protocol, which is the classic one. An additional phase here is quality, which is a way by which you can introduce things like censorship resistance, for example. So the orange box might be a block producer that could have a high power, and that block producer would advertise a totally new block, but because of the quality round, where we only select blocks that are prefix of previously finalized blocks, then the network would eventually converge on the popular prefix, if you like, rather than relative to the previous finalized blocks, rather than allowing a specific node with a specific amount of power to do censorship attack, which is quite a nice property. F3 itself is not just F3. One of the key features of F3 is this proof of finality. And the most important thing you need to remember about proof of finality is that it is transportable. And that has huge implications for bridge building. It not also has finality certificate, but it also has this thing called finality exchange protocol, which comes with a already written way by which you can send and receive these finalized and portable proofs of finality. Now, if you think about what this actually means, it means that if you're building a client, you no longer have to trust that big full node to tell you what the world is, because you can simply listen to the ambient noise in the world, because gossip swap just propagates everywhere, and you can infer for yourself that whether the message that you asked to be finalized is actually finalized. What is the head, right? And that is a huge game changer in terms of building bridges, because you don't have to rely on on full nodes anymore. You're all building a decentralized network. It has to work trustlessly, and that's what it enables. There is a FIP that explains all of these things that I've confused you with. It is one of the very well-written FIPs out there, as you can tell by the amount of intellect in the writers section. I highly recommend going and reading that FIP. It is at the very final stages of basically getting through. There are basically the final tiny little changes depending on implementation that are being worked on now, but it is essentially final. I highly recommend reading through that. It's easy to read. Also, I think it's definitely worth understanding how this works if you're building bridges on top of it. So diving a little bit deeper into implementation. So there is a repo called GoF3, which is the implementation of Fast Finality right now, F3 Fast Finality. It implements a few things. First one is the Gossip BFT consensus protocol, the core consensus protocol. It implements the F3 layer, the way by which we interact from Gossip BFT to other nodes such as Lotus and so on. It implements finality certificates. It also implements finality certificates exchange with a bonus adaptive pulling mechanism, which Stephen Ritting, sitting right over there, worked on. That's very sweet. I highly recommend looking that up. If you're into understanding F3, there are two packages that I highly recommend checking out. One is called SIM, or simulation. It allows you to simulate an entire network, different adversary models and so on, and just see the F3 working for itself. This is the package that we use for testing the whole thing. And if you're a protocol designer or you want to interact with Gossip BFT as a consensus protocol, there's another package called Emulator, which allows you to send messages one by one and assert state of basically F3 actor, if you like, if you think of it as an actor mode. So why should you care? Anybody? This is all good and cool, right? So why should you care at all? This all sounds like stuff, right? There's a lot of stuff, right? So the first one is straightforward. I'm going to go through it. It's my favorite slide. 450 times faster. This is pretty damn good, right? We've gone from 900 epochs to 2 epochs. That is pretty good. But I honestly think this is not just a thing to think about, right? It's not just that it's fast. What it actually is that its finality is actually finality, right? So we've got fast and we've got finality. Those are valuable when they come together. If you have a system that is fast but finality changes all the time, you still have very bad quality of service for your users as a bridge builder, right? If the finality is final but it's not fast enough, which is sort of what we have now, you can't ask for Web 2 style users to wait for hours for some transaction completion. It is the combination of both in F3 that makes a huge difference. So I'm going to take a step back and look at this holistically. So far, we talked about fast. We talked about finality. We also know that for this whole thing to work, we are using Filecoin's unique staking mechanism, which uses both hardware as a storage capacity proof and so on, as well as a monetary staking. Right? This is pretty unique to Filecoin. And all of that translates to one of my favorite quotes that I got from a friend asking, what do you think about F3 in the context of bridges? And he told me, unparalleled security for both individuals and cross-chain bridges. So I'm gonna repeat this. You've got fast, 450 times faster than before. You've got finality that does not change after 2 epochs. And you've got unique features of Filecoin, which does hardware plus monetary staking. And what you get is unparalleled security for both individuals and cross-chain bridges. Nobody else has that. So if you're in the business of bridge building, you should do that now. You should go and play with F3 right now. So do you remember my slide of saying you have to pick between trustless or low cost? Well, with F3, after MV24, hopefully when we get it shipped, you can have both of these. You can write a client that is completely trustless, sends messages over the network, listens to the ambient noise, and asserts that a head has happened, a head has been finalized, completely trustlessly. And you can run it in a low cost, in that you do not have to run a full node in order to communicate to the network, in order to assert finality. You can just run your little client that sends messages with fee paid for to any node and just listens to the ambient noise and say, is it finalized yet? Is it finalized yet? Yes, great. And all of that happens within two epochs, right? That is pretty powerful. What is next for F3? At the moment, we are in the process of this thing we call passive testing. The QR code points you to a document that F3 engineering team has written, explains the rationale behind passive testing and what it entails. Essentially, I personally feel extremely lucky working on this project because it's not often you get the chance of swapping the EC protocol in a live network. So it is an extremely delicate but also exciting opportunity for me personally. And also, just knowing myself, I know that I'm going to engineer some kind of bug in it at some point or miss something in a review or whatever. So with the team, we came up with this idea of passive testing. And passive testing is essentially releasing everything about F3 in a live network, but not letting in effect the EC. So we are observing the network just like a light client would. Do you remember I talked about trustless clients? And we are asserting that the EC progresses as it should, the number of rounds that happen are reasonable, and so on. And then hopefully in NV24, we switch the whole thing on, and we just watch the network grow. We should be pretty excited. There is another item that is, we sort of think about just a long range, long-term thinking. This is an idea that came up with discussions with Kuba. Right now, we're basically building everything with zero-knowledge proofs in mind. So right now, once F3 is released, in order for you to assert finality has happened, you need a chain of all the certificates that has happened before. So the way that it would work in practice is that there's somewhere that has a well-hosted, well-known list of all the certificates that gets updated, a bit like a snapshot. And then you can listen to the network and update your own certificates as they get produced, right? And in order to verify the correctness, you basically have to verify the chain, just like a blockchain. You go back and verify all the certificates. So it has ON characteristics, when N is the number of finality certificates. With the zero-knowledge proofs, you can do that with just one certificate, which would be pretty awesome. But obviously, it's a long road to get there. The main thing to point out here is that from day one, when we've built the protocol and implemented it and made adjustments to the FIP, we kept this type of improvements in mind. So yeah, watch out for that. Thank you so much for listening to me. Just want to point out, almost all of F3 engineering team is in FDS right now. Myself, Kuba, Step. Please come find us and ask if you have any questions. Happy to help you. And also the Slack channel on Slack. Thank you so much. Cheers.